Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to Doctor and also to all my friends. So today I would like to present the experiment 2, and the task that I've been given is task D and E. Task D is carboxylic acids, amides and esters, and for task E is amines. So before getting any further, let me introduce myself first. My name is Nur Farana Suha binti Muhammad Hassan Amri. My metric number is 17205953 from Occurrence 1, and my lecturer is Dr. Abdullah Al-Hadi bin Ahmad Fuad. So first of all, we're going to start with the title of the experiment. The title is Chemical Properties of Hydrocarbons, Alcohols, Aldehydes, Ketones, Carboxylic acids and amines. So the objectives of this experiment is to identify the functional groups in compounds. Next is to be able to describe the structure and properties of functional groups such as aldehydes, ketones, carboxylic acids, esters and others. Lastly is to explain why the properties of a given organic compound are largely dependent on the functional group or groups present in the compound. So there are a few experiments that I've recognized based on the given videos. The first one is from section D. It is the reaction of carboxylic acid with sodium bicarbonate solution. The second one is section D, the test for the ester. And the third one is section E, the Hinsberg test for amines. So we're gonna see the first one, the first experiment, which is reaction of carboxylic acid with sodium bicarbonate solution. The carboxylic acids that involved in this experiment is ethanoic acid and also benzoic acid. Next, we go on to the procedure. First, 1 milliliter of 5% sodium bicarbonate solution was placed in a watch glass. Second, 1 to 2 drops of carboxylic acid or 0.1 gram if solid was added. And the third one, observation was recorded. So down there I've put the reaction, which is carboxylic acids that react with sodium bicarbonate solution will produce the carboxylate anion and carbon dioxide gas and also water. And now it's time for the results. For compound ethanoic acid, I put clip 76 as its observation because in that clip, what I'm observed from that clip is there is a lot of small bubbles immediately appears. The next one is compound benzoic acid. I put the clip 77 and what I'm observed from that clip is the solid is moving a little bit and only some tiny bubbles appears. So next we are going to the best part, which is discussion. So as you can see, I put a little note up besides the discussion which says strongly acidic compounds such as carboxylic acid will react with sodium bicarbonate solution to form the water-soluble salts. And the reaction also produces bubbles of carbon dioxide. So the bubbles that appears from our observation is actually carbon dioxide, and it appears because the reaction of sodium bicarbonate solution with these carboxylic acids. Okay, so for ethanoic acid, it dissolves in sodium bicarbonate solution, and it dissolves in that solution faster than the benzoic acid because, as we can see, the small bubbles appear quicker and faster, and also a lot more bubbles appears in the ethanoic acid when it reacts with sodium bicarbonate solution. So what we can conclude that it has a smaller number of carbon, as we can see in this molecular formula, and shorter chain length, thus make it react faster in the basidic solution. For the benzoic acid, it dissolves in sodium bicarbonate solution, but however it dissolves slowly in that solution and slower than the ethanoic acid. So this is because it has a benzene ring at longer chain length, therefore make it react slower in the basidic solution. So now we are moving on to the next experiment. This experiment is the test for ester, and the esters that involved in this experiment is ethyl acetate and methyl benzoate. So the procedure for this experiment is first 1 to 2 drops ethyl acetate was added to a saturated alcoholic solution of hydroxylamine hydrochloride, 3 drops, and a methanolic solution of 20% potassium hydroxide, 3 drops, in a test tube. And then the mixture was heated to boiling, and the mixture was cooled and acidified with 0.5 molar hydrochloric acid hydrochloric solution, and then iron trichloride solution was added drop by drop to the mixture. And then after that, the observation was recorded and the test was repeated with methyl benzoate. So down there I put a reaction scheme, which is the ester will react with hydroxylamine in the presence of the sodium hydroxides to form the sodium salt of corresponding hydroxamic acid. So on acidification and addition of the iron trichloride, as it's shown in the procedure, and then the magenta colored iron 3 complex of the hydroxamic acid is formed, and when the magenta colored solution is formed, that means it is ester. So now moving on to the results. For compound ethyl acetate, I put clip 78 as my observation, because in that clip what I can observe is a brown reddish solution or the magenta colored solution. And then for compound methyl benzoate, I choose the clip 79 because in that clip I can observe a brown purplish solution, which is burgundy colored solution. Next, we're going to discuss about the test. So the first compound is ethyl acetate. So we can say that it is an ester because it produces magenta solution, which indicates the magenta colored iron 3 complex of the hydroxamic acid. So that's why we can know that it is ester. And then the next one is methyl benzoate. It is also an ester because it also produces magenta sort of an burgundy solution, which indicates the burgundy colored iron complex of hydroxamic acid. Now the third test is from section E, which is amines, and the test called Hinsberg test. And the amines that involved in this test is propylamine, diethylamine, triethylamine, aniline, N-methylaniline, and N,N-dimethylanine. The procedure for this test is 5 ml of 10% sodium hydroxide solution and 0.4 ml benzene sulfonyl chloride were added to 0.3 ml of propylamine or 300 mg if solid in a test tube. Then the test tube was toppered and the mixture was shook vigorously. The solution was tested to make sure that it is still alkaline. After all of the benzene sulfonyl chloride has reacted, the solution was cooled and the residue was precipitated from the solution, if any. And then the solution was treated with 10% acid hydrochloric solution and observations was recorded. So if it is primary amines, it will dissolve in base and precipitate in acid. And then if it is secondary amines, then it have the precipitate in base but no change in acid. And then for the tertiary amines, it will precipitate in base and dissolve in acid. And the test was repeated by using propylamine, diethylamine, triethylamine, aniline, N-methylaniline, and N,N-dimethylanine. So the next slide is the reaction slide. So the first one is primary amine. When primary amine is reacted with benzene sulfonyl chloride in a base solution, then it will dissolve in the base solution. However, when it reacts in the acid hydrochloric solution or the acidic solution, then it gonna form precipitate, which is a sulfonamide salt of sodium. It gonna precipitate the salt. Okay, and then the next one is secondary amine. Secondary amine, when it reacts with benzene sulfonyl chloride in the basic solution, then it will not dissolve in that solution and will shows precipitate in that solution. And after that, if the secondary amine react in um, the acidic solution, then it will no reaction will occur. The next one is tertiary amine. When tertiary amine react with benzene sulfonyl chloride in a basic solution, then it will not dissolve in that solution. It will not dissolve in the basic solution. However, it will dissolve in the acidic solution. So next, let us see the results of this test. But first of all, we can't record the observation in base because we didn't have the videos for the observation. So we just record the observation in acid. So for the first compound, which is propylamine, I put the clip numbers 80, which is in that clip. It shows that there is a white suspension formed. Okay, and then the second one is diethylamine. Diethylamine, I put clip 81, and in that clip I'm observed that there is small white precipitate form. And then the next one is triethylamine. I choose the clip 82, and what I'm observed from that clip is there is like a brown solution. And then compound number 4, which is aniline, I chose clip 83, and in that clip what I can observe is a murky solution. The next one is N-methyl aniline. I chose the clip 84, and in that clip what I observe is the slightly brownish solution. And the last but not least, the compound N,N-dimethylamine. I chose the clip 85, and in that clip I see what I'm observed is a colorless solution. Next, we are moving on to the discussion. For the first compound, it is a primary amine. Propylaniline is a primary amine because white suspension is formed after the reaction with acid solution. This amine is react to the acidic solution and formed sulfonamide salt of sodium. So that's why we call it as a primary amine. The next one, the second compound is diethylamine. Diethylamine is a secondary amine because it didn't react to the acidic solution. However, what I observed from the video, that the small white precipitate that is formed, it is probably because of the reaction between diethylamine and the base solution before. And then the third compound, which is triethylamine, is a tertiary amine because it dissolves in the acidic solution, and then it appears to be a brown solution. Okay, so before moving on to the next compound, I just want to make it clear that this Hinsberg test, is to test and to distinguish between primary amines, secondary amines, and also tertiary amines by their reactions with benzene sulfonyl chloride in acid solution and in base solution. Okay, now we are going to see the fourth compound, which is aniline. So aniline is a primary amine because the murky solutions that appeared in the test tube shows that this amine didn't dissolve in the acid solution. The next one, which is the fifth compound, is N-methyl-aniline. Is a secondary amine because the brown colored solution that I'm observed is probably due to the reaction in base solution. Then after that, if it is in the acid solution, there is no reaction in the acid solution. Okay, and then the next one, the last compound is tertiary amine, which is NN-diethyl-aniline. NN-diethyl-aniline is tertiary amine because of the absence of any precipitate and only produce colorless solution. So it means that it dissolves in acid solution. So this compound is tertiary amine. After all of the experiments by the given task had been accomplished, now we are moving to the precaution steps. So the safety precautions are: do not use thumb as a stopper. Use a stopper instead of using a thumb. And then swirl gently or put a piece of parafilm over the opening to mix solutions. Because we don't know, either the solution might be harmful or corrosive to our hands. Next, do not pour reagents and chemicals down the sink. However, dispose this only in designated waste bottle or container. This is because the spread of the chemicals down the sink will be able to cause harm to other lives. Then, when using hot plates, make sure to unplug them before leave. And lastly, if the glassware broken accidentally, clean up with broom and dustpan, and remember to dispose the broken glass in the designated containers so that other people won't be get harmed by it. The next slide is conclusion slide. So after all the experiments that had been carried out, we are able to identify the functional groups in compounds. Next, we are able to describe the structure and properties of functional groups such as aldehydes, ketones, carboxylic acids, esters, and others. And we also be able to explain why the properties of a given organic compound are largely dependent on the functional group or groups present in the compound. And conclusionally, all of the objectives have been achieved. Last but not least, these are the references that I've used to make this slideshow. Okay, then that is all from me, and thank you so much for listening. Assalamualaikum.